Hi gang, time to balance chemical equations. What I'd like you to do, if you can print the link out, the worksheet on today's agenda. It says balancing chemical equations. You can print it out, or if you can't print, which many of you probably don't want to print, that's fine. Great for me, because I want to see you save ink. Just copy down these chemical equations on a sheet of scratch paper. Copy them down as they are, and then solve them by watching my video. Learn how to balance chemical equations. Okay? Chemical equations have to have the same amount on the left side as the right side, as we've been talking about. Law of conservation of mass. Same amount of reactants as products. Here's your change, which is the arrow. So we're going to balance by, first of all, counting the atoms on each side. We learned about that. It was a skill you acquired in the beginning of all of this. You counted atoms. And then we're going to add coefficients to balance them. We're going to start off easy by doing the first four problems that are they're simpler, because this is a hard concept. We're going to do this equation, and on the second sheet we're going to do the top one here with the magnesium, and right here with your water. Okay? The other ones are harder, more difficult. There'll be a part 2 video for the other ones that'll walk you through that. More challenging, but I'd like you to do these basic ones with me here. So first of all, we have this equation. We have sulfur. It combines with oxygen, and that's basically the burning of sulfur. And when sulfur burns by combining with oxygen, it makes this sulfur trioxide. And that is one of the leading products that create acid rain. Sulfur combines with oxygen and gets in the atmosphere, and another chemical reaction takes place, and that acid rain comes back down on us. First step, all you got to do is list the elements on each side. So I see sulfur on the left side, so I write an S. I see oxygen on the left side, so I write an O. Same thing on the right side as on the left side. You write an S, you write an O. How easy. Now we count the atoms. So how many sulfurs do I see on the left side? I see one. I'll put a little dash there to separate it. How many oxygens do I see on the left side? I see 2. How many sulfurs on the right side? I see 1. How many oxygens on the right side? I hope you're thinking 3. So as you can see, in this chemical reaction, it is not balanced as of right now. There's 3 oxygens to 2 oxygens. That's not balanced. The sulfurs are balanced. When I look at 2 and 3, I think of the lowest common multiple between those, 2 and 3, is a 6. 2 and 3 divide into 6 evenly. So we have to sort of arrive at 6 on both sides. So up here, we add a coefficient of what number to get 6 oxygens. I'm hoping you're thinking about a 3. So by putting a 3 there, 3 times 2, we cross out the 2 and change that to a 6. On this side, to get 6 oxygens, we're going to have to put a 2 here. And that takes our oxygens from 3 to 6. Now we're balanced with the oxygens, but I hope you're seeing this. Because I put the coefficient of 2, the 2 applies to the sulfur as well. So we have to change that 1 to a 2. So in the process of balancing the oxygens, we have sort of accidentally unbalanced the sulfurs. So now I have 2 on the right and 1 on the left. If we go over here and look at the sulfur on the left side up here, I wonder how we could get 2 sulfurs. And I hope you're thinking, hey, just put a 2. So by putting 2 coefficient on the left side, we now can change that to a 2. And we have now balanced sulfur on each side, oxygen on each side.